Here's a quick look at number 8 on homework 6. My thought is that maybe a number of people got stuck on this, and if you survived it, there's a chance you just survived it in any way you could, which is using technology to get that derivative. Because I didn't show you, this is kind of a mistake that it ended up in here. It's resolvable, so I'm going to help you get through number 8 with the techniques that we have. It's just calling up on some algebra you may or may not remember. So to tackle this one, what I would do is I would take that x that's outside the square root, because the goal is to get the equation of the tangent line. And so if I were to, what I need is the equation of the tangent line requires the slope at the point of tangency, and that's where the derivative kicks in. So yes, this function you're given, you're going to take the derivative of for the sole purpose of getting a slope of the tangent line. The rest of the equation we have to write out in that y minus y1 equals m times x minus x1 form. So we're going to go get a derivative just to get the slope, and then we'll go and do the rest later. But first, we had to take the derivative, and that requires this technique until we learn the product rule, which is pretty shortly. But if I take that x outside the square root, I can put a number multiplied by a square root back in the square root. But you have to square it, because square rooting undoes squares. I'm putting it back in. And you can only square root things that are being multiplied together, like individually. So I'm going to put a little reminder in here. So you may, so what I did is, if you see that x went inside, it became x squared. And when I take the square root of x squared, it comes back out as x. So you can write it either way. These are equivalent expressions. Both what you see on the screen right now, those are equivalent. So next is, here's an example. Square root of 32. You may remember simplifying radicals. We could make it up as 16 times 2. And because those numbers are multiplied, I can take the square root of them individually. The square root of 16 I know is 4. The square root of 2 I don't know, so I just leave it square root of 2. So we used to write this as 4 times the square root of 2, because I was able to take the square root of the 16. All right, so back to the problem at hand. What I'm going to do is, because I put the x back in the square root as x squared, I can distribute it in those parentheses. So that's x to the 4th plus 21x squared. And then if you notice, that's a square root, which you can write as a 1/2 power. That means this is a chain rule, like we've recently taken on. So I can write this as that expression to the 1/2, perfect chain rule scenario. I'm going to go to another page and take that on. So if you turn with me, here is, I'll rewrite this function, and we'll go ahead and do the chain rule to take the derivative of it. And things that go into the chain rule, derivative of the outside with the inside untouched, and then times the derivative of the inside. You may need to watch it again. Derivative of the outside with the inside untouched times the derivative of the inside. That's how we tackle the chain rule. So there it is. Then with that in hand, I can find the slope at x equals 2, because that's what the derivative does. I need that for my tangent line equation. So I'll put 2 in. I'm going to use Desmos, and so if you watch with me, I'm going to go to I have my computer all set up. Here's my function f of x. If you want to look at the graph, it's over here in blue. And if you want, and you can zoom out a little bit longer, it kind of starts curving after a while. It looks kind of straight at this point. The derivative then is right below it in red. And so that's graphed up there as well. We don't need to look into that. I can open this up. That's what I just came up with. So if I open this wee bit, if I can, I'll try. Can't really get that to move. There it is. That's the whole function for the derivative. What I've done is I need, g is what I've named my derivative. So I put 2 in it. So down here I put g of 2, and I get 5.8, which is also, I think, like 29 or something. So that's 5.8. That's the slope I need. And then I also need, it didn't give me the equation, or it didn't give me the x coordinate point. It says, please find the slope of the tangent at 2 f of 2, which is, I need to go find out what that f of 2 is. That's my y coordinate. So I put it in, got 10. So the point I'm actually getting a tangency to is 210. All right, so now, and that point would be right about there if I'm looking for an equation of a tangent. So back to my drawing board. If I pull this up here, from there, so I've got this f prime of 2, and I just found out that it is 5.8, and I'm going to use that with the point 2 comma 10, because I just found out that's the point it goes through. This was f of 2, and I found that out in a little calculation. I'm using a calculator to my advantage. Now the equation of the tangent line, remember, is y minus y1, and that equals m times x minus x1. And we'll just put those values in there, and I'm going to put them in a different color, erase some things along the way, but my y1 is going to be 10. My slope is going to be that 5.8 that I just came up with, so 5.8 goes in there, and then the x is the 2. the x-coordinate. That's my equation. That's all great. But you'll notice on WebAssign it wants y by itself, and it doesn't need you to simplify much, but you can simply just go y equals 5.8 x minus 2 minus, wait, no, plus, because I get a minus 10 on the other side, so I add 10 to both sides. This is the equation that you can enter in for your y equals. And then I think it says provide a graph of it. If you want, since I did it in Desmos, if you go back there, you're welcome to do that as well. You can take a peek at it and see which one of the graphs provided matches. And I think there's maybe one other question related to that, and I'm sure you could handle it now from here. So email if you have other questions. I figured this would be kind of a healthy help.